In 1979, an engine fell off a DC-10 during takeoff in Chicago. 273 people died, and that single moment almost killed every three-engine jet in the sky. But here's the thing, the DC-10 wasn't actually the problem. So what really happened to Trijets? And why don't they exist anymore? Back in the 70s, jet engines used to fail. Not always, but enough that regulators made a rule. If you're flying a twin-engine plane, you had to stay within 60 minutes of an airport at all times, which meant twins couldn't cross oceans. And airlines absolutely hated that restriction because passengers wanted direct flights to Europe. The 747 could do it because it had 4 engines and tons of range, but the only problem was that it seated 400 people, and most routes didn't need that many seats. Flying a half-empty 747 was just burning money, so they decided to build something smaller with 3 engines. Boeing proved it worked with the 727 in the 60s. It was a smaller plane that could land anywhere, and over 1,800 of them were built. It dominated short routes for decades, and showed that the Trijet concept actually made sense. But for long-haul flights, you needed something bigger, so 2 companies went for it. McDonnell Douglas made the DC-10, and Lockheed made the L-1011. They look almost identical, right? But if you ask pilots, they'll tell you these were totally different airplanes in how they actually flew. The L-1011 had this wild S-shaped air duct feeding the tail engine. It was super complicated. It added a ton of weight, and it was expensive to build. But it made the plane ridiculously smooth to fly. One pilot described it like this:
"It didn't just fly, it floated."
You could feel it breathing with you. That's how good it was. The DC-10 went simpler with a straight duct, lighter structure, and easier maintenance requirements. But that approach created its own airflow headaches down the line. And for about 15 years, Trijets were everywhere, and they kind of owned long-haul flying. But then in 1979, everything fell apart in the worst possible way. Because in 1979, American Airlines Flight 191 was a DC-10 taking off from Chicago when the left engine fell off during takeoff. The plane rolled, crashed into a field, and 273 people died. But here's what's kind of wild about this whole thing. The crash wasn't actually caused by a design flaw in the aircraft itself. American Airlines had been cutting corners on maintenance. Instead of removing the engine and the pylon separately like you're supposed to, they'd just pull the whole thing off together with a forklift, because it saved time and saved money. But doing it that way put stress on the pylon, and cracks formed that nobody caught. And on Flight 191, the engine just ripped off because of those hidden cracks. So the DC-10 wasn't inherently dangerous as a design, but the damage to its reputation was permanent anyway. Airlines quietly started getting rid of them, and passengers flat out refused to board them. And Flight 191 wasn't even the only issue. The DC-10 had cargo door problems that caused explosive decompressions, hydraulic systems that could all fail at once if you lost the wrong engine and structural weak points in the tail section. Some of these were design flaws, some were maintenance issues, but they all fed the same narrative. 3 engines meant more complexity, more failure points, and more things that could go catastrophically wrong. And that raises an interesting question. If the DC-10 died because of bad press and real structural issues, then what killed the L-1011? The L-1011 was probably the better plane, and honestly, it had more advanced tech, a way smoother ride. And pilots also loved it, but it had one massive problem that had nothing to do with the aircraft itself. Its engines were made by Rolls-Royce. And in 1971, Rolls-Royce went bankrupt. Engine production stopped completely. Deliveries got delayed for months. Airlines started canceling their orders left and right. And here's the tragic part. Lockheed had invested everything into this plane. Their entire commercial future depended on it. When Rolls-Royce collapsed, Lockheed had no backup plan. And by 1984, they just stopped building the L-1011 entirely. And that's how one of the safest, most advanced planes ever made was killed, because an engine company went broke. Engineers who worked on it still talk about it with this quiet sadness, like they watched something perfect die for no good reason. But even if Rolls-Royce hadn't collapsed, and even if the DC-10 crash had never happened, Trijets were already on borrowed time. Because here's the thing nobody was really asking back in 1979. What if twin-engine planes just got good enough to cross oceans safely? Because in 1985, the FAA introduced something called ETOPS, which stands for Extended Range Twin-Engine Operational Performance Standards. It's a terrible name, honestly, but it changed everything about how airlines could operate. Basically, if your twin was reliable enough, you could now fly up to 120 minutes away from an airport, which meant twin jets could suddenly cross the Atlantic safely. And they were just better at it in every measurable way. They were lighter, more fuel efficient, and way easier to maintain. Changing an engine on an L-1011 took days because you needed special equipment, but on a 767, you could do it in a few hours. That difference alone changed the economics completely. And by 1988, ETOPS went up to 180 minutes, which meant twins could fly basically anywhere in the world. So the obvious question becomes, why would you bother carrying a third engine anymore? And this is where it gets really interesting from an engineering perspective. There's this engine called the GE9X, and it's what they put on the 777X, and it makes 134,300 pounds of thrust. Now, a DC-10 had 3 engines, and all of them together made about 125,000 pounds. So one modern engine has more power than an entire Trijet had. One engine, not 2, but 1. That's how far engine technology jumped in just 30 years. So by the 2000s, the economics were pretty straightforward and honestly kind of brutal for Trijets. 3 engines meant more weight to haul around, more drag slowing you down, more inspections to complete, and higher operating costs across the board. And for what benefit? Twins were now just as safe, more efficient, and way cheaper to run. The math just didn't work anymore for 3 engine designs. But McDonnell Douglas wasn't ready to give up yet, so they made one final attempt. In 1990, they introduced the MD-11, which was supposed to fix everything wrong with earlier Trijets. It promised better fuel economy, longer range, and all new avionics systems. But it didn't live up to the hype at all. It burned way more fuel than they promised, couldn't hit the range numbers they advertised, and pilots said it was genuinely difficult to land safely. One cargo pilot described it like this:
The MD-11 doesn't forgive. You come in wrong, it'll bite you. I've seen it throw guys around on touchdown, like they forgot how to fly.
Airlines lost interest pretty fast after hearing stories like that. So who actually kept flying it after the passenger airlines gave up? Cargo operators like FedEx and UPS kept them going. They didn't care about passenger comfort or tricky landing characteristics. They cared about how much stuff you could cram inside that long fuselage. And by the early 2000s, used MD-11s were dirt cheap to buy. KLM flew the last passenger MD-11 in October 2014. After that, it was just packages and freight. FedEx and UPS were still flying them as recently as 2024, operating about 57 MD-11s between them. But just a few days ago, on November 4th, a fatal crash involving a UPS MD-11 occurred in Louisville while taking off. Following the incident, aviation authorities ordered both UPS and the other involved airline to ground their entire fleets. Whether they'll return to the skies remains unclear, but this crash has dramatically accelerated the MD-11's decline, bringing the Trijet's extinction even closer. By the 2000s, ETOPS ratings for twin-engine planes reached 180 to 240 minutes, which meant twins could fly most routes on the planet safely. A twin-engine plane could now be 3 to 4 hours away from the nearest airport and still be perfectly legal. That's deep into the Atlantic or Pacific. And like we said earlier, one modern engine now makes more power than 3 older ones combined. Trijets solved a problem perfectly, but then the problem just went away. But I think there's something worth understanding here beyond just the technical stuff and the numbers. This isn't really a story about engines or regulations when you step back and look at it. It's about how solutions have expiration dates, and how being perfect for one era doesn't guarantee survival into the next. The Trijet made perfect sense in 1975. The technology of the time demanded it. Airlines needed it, and passengers trusted it. But technology doesn't stay still, and it never has. Engines got more reliable, regulations adapted to new realities, and new designs showed up that did the job better. And suddenly that third engine wasn't providing safety anymore. It was just dead weight, extra cost, and a maintenance headache. The thing that made Trijets brilliant in the 70s made them obsolete by the 2000s. The Trijet didn't fail because it was badly designed or poorly thought out. The L-1011 was probably one of the best commercial planes ever built from an engineering standpoint. The DC-10, despite its reputation, was actually pretty solid once they fixed the maintenance issues. Even the MD-11 had its strengths in certain roles, but being good isn't enough in the long run. You have to stay necessary, and that's what they couldn't do. Trijets had their moment in history. For about 25 years, they were the backbone of long-haul aviation. They connected continents, They pushed the boundaries of what was possible, and they did their job well. And then engine technology caught up, regulations changed, and twins took over. That's really all there is to it. The Trijet solved a problem, then the problem went away.